All right. At some point in your math career, not at some point, in geometry class, specifically trigonometry, you studied a little bit of this. And the trigonometry that you're going to need for this class is really the most basic of trigonometry. But I'm going to give you some notes here just to refresh your memory in case it needs refreshing. So, first of all, what's trigonometry? A trigon, a polygon. Polygon is like many-sided figure. Tri means three, like a tricycle. Trigon. Trigon is just like a fancy way using word roots from, I think that's from Greek. That's a triangle. And ometry, it's a study of. So trigonometry is a study of triangles. In particular, we're going to be interested in right triangles, which is good news for you, because right triangles are the easiest ones to deal with. So let's say I've got a triangle here. It's a right triangle. And there's the right angle there. Remember that trick? You put a little box there to say to the world, look, look, that's the 90-degree angle right there. It's a little box. And let's call this angle down here the angle theta. Theta is the sort of go-to variable for angles. And you probably know that. Now, in keeping with the way that we plot points, I'm going to go ahead and call this x, and I'm going to call this y. Why not? Because that's how we plot points. And what should we call this? There's different things that we could call this. I'm going to call it, I guess I'll call it h for hypotenuse. Sometimes you see that called r, because you think of it as being like a radius of a circle, if you know about the unit circle and stuff like that. Anyway, it doesn't really matter what we call these things. What we need to know is what is the relationship between them, and how do we use the trig functions, sine, cosine, tangent, and their inverses. So do you remember this? I think I mentioned this in some other video you saw from me recently. SOHCAHTOA. Different teachers present different little mnemonic devices for remembering this. Some old hippie caught another hippie tripping on acid. That's the sort of like, ooh, that's like, is that school appropriate? I don't know. It's kind of funny though. And then if you want to make that more like rated G, you could do some old horse caught another horse taking oats away. But probably at this point for you, you don't need those anymore because you just SOHCAHTOA. When I learned this, sorry I'm repeating myself from the other video probably, but we just learned to say SOHCAHTOA. And what you really need to remember is that these mean here, sine is opposite over hypotenuse. So the sine of an angle, theta, is equal to opposite. I'm going to refer to this triangle. So opposite, sure, but opposite to that angle there is the y over the hypotenuse. And cosine of theta is equal to adjacent. If you're wondering, like, wait, how do I know if these two are both adjacent? When we're talking about the opposite and adjacent, we're talking about the short sides, not the hypotenuse, right? So that's x over h. And then tangent theta, that's OA, that's opposite over adjacent, opposite over adjacent. So that's important to know. And then what if you needed to find that angle? What do you do then? Sometimes we know the sides and we need to find an angle. So if you need to get that angle out of there, that's when, or in other words, if you're like looking at this equation, probably always a good idea to just write this down for whatever you're interested in. So sine of theta is equal to y over h. That means theta is equal to the sine inverse of y over h. That's how that works. You move that to the other side. If you're looking for an angle, you're going to be using one of the inverse trig functions. and I'll show you in a minute. But to get those on your calculator, that's where you do second, and if you wanted sine inverse, second sine gives you sine inverse. And if you want cosine inverse, you're going to do the cosine inverse of adjacent over hypotenuse. That'll give you an angle. And in physics, this is the one that we probably use the most for finding angles. It's most common that we know the two legs. So to find that angle, you'd use tangent inverse. And let's see, what else? Also, you know that this is a right triangle, so by the Pythagorean Theorem, you know that x squared plus y squared equals h squared. The Pythagorean theorem is often a squared plus b squared equals c squared, but that's just the sides named different letters. So here we named them these, so that's the Pythagorean theorem. So if you know two sides in a right triangle, you can find the other one by doing that, doing some math. Okay, so that's pretty much everything that you need to know about trig. If you can do all of that, then you're home free. So let me just do a quick example for you. So let's say we got a triangle. Maybe I'll do two examples. We'll see how this one goes, if I feel like we've got enough. And let's say we've got this angle here, and we've got, I know that this side is 3, and this side is 7. Let's say that. So what are the things that we don't know? We don't know this angle. Let's say we know it's a right triangle, and we have two sides. And if you need two angle variables, the first to go to is theta, and the second one is phi, which looks like this. And so here, there's three angles in the triangle, 1, 2, 3. I know one of them, that's 90, right, because it's a right triangle. And the sides, 1, 2, 3, I know two of them. So I know a total, besides knowing it's a right triangle, I know two pieces of information. And that's enough to quote-unquote solve the right triangle. What does that mean, to solve the triangle? I'm not a big fan of that terminology. It just means to figure out all the stuff that we don't know. So let's do that. Let's figure out all the stuff that we don't know. You want to find x? Want to do that first? Sure, let's do that. So if I want to find a side, and I've got two other sides, I can't use any of these trig things yet because I don't know any angles. So here, let's use the Pythagorean theorem. X squared plus 3 squared equals 7 squared. So x squared is equal to 7 squared is 49 minus 3 squared is 9. So x is equal to the square root of 40, which is fine, I guess, but in physics class usually we want actual like decimal numbers. So I'm going to go ahead and do that. So let's call that 6.3. That's good enough. Don't be writing down all the numbers all the way across your screen. Nobody wants to see that. Give me like 1 or 2 decimal places, be fine. All right, so that's 6.3. Okay, now how do I find those angles? I've got some options now because I know all three sides. So I could actually do any one of these. I'm going to, since this is a number that I rounded, I'm not going to get mad at you if you choose to use this number, but I'm going to go ahead and use the two that were given in the problem. So with this angle, this is the opposite one to it, and this is the hypotenuse. Opposite and hypotenuse. Opposite and hypotenuse. So that should draw me to the sine function. So if I want to find the angle, that angle is the sine inverse of opposite over hypotenuse. So I'm going to make sure when I go to the mode that I'm in degree mode. I'm not. If you are in some kind of like pre-calculus class, or I don't know what math class you're in, you've got to watch out. If you're in a math class that requires you to use radian mode in your calculator, you're going to have to watch out for that. If you get a weird answer, for me, just as a force of habit, whenever I use trig functions in my calculator, I always go to check what mode I'm in just to make sure that it's the right one. Okay, so I'm in degree mode now. So I want to do the sine inverse, that's second sine of 3 over 7. So I got about 25 degrees. You could do 25.4 if you want. I think I'm just going to round it to the nearest degree. 25 degrees. Okay, how are we going to find this angle? Well, there's a few ways that we could do that. I mean, you know the angles of a triangle add up to 180. So if this is 90 and this is 25, this has to be 65. Right? No, I mean, that's it. Nothing else for us to do there. You could also do phi is equal to, what would it be if I use these two? Well, this is, the 3 is adjacent to this angle phi, and that, so it would be the cosine inverse of adjacent over hypotenuse. And I could just make sure that I get that 65. Of course, it has to be that. So cosine inverse of 3 over 7. Fingers crossed, it better be 65. Yep. You know what you get if you add those two things together? You got it. You get 90. So that's 65 degrees. And that is a solved triangle. There's nothing in that triangle now that we don't know. So I think that's enough as an example. Just depending on what two pieces of information you have might steer you in different directions for what you want to use. So you have an assignment now to a few problems to try, and you can refer back to this video. You should write these things down and have them in your notes right next to you so you can do it successfully.